Welcome back to Cosmic Chronicles. Today, we're journeying back to Mars, but not to the ancient riverbeds or towering volcanoes you might expect. Instead, we're looking at some fascinating new clues about its icy past, hidden in plain sight on its surface. Recent analysis of super-sharp images from NASA's Mars Reconnaissance Orbiter, specifically its HiRISE camera, has revealed something truly remarkable: peculiar wave-like patterns in the Martian soil. And here's the kicker. They look almost identical to features we see right here on Earth in our coldest, most rugged mountain landscapes. Scientists call these earthly features solifluction lobes. Imagine soil in places like the Arctic or the high Rockies getting loosened by constant freezing and thawing. Over time, this slushy soil slowly creeps downhill, forming these distinctive wave-like lobes, a bit like paint slowly dripping down a wall. Finding similar patterns on Mars is a big deal because it suggests the red planet might have experienced very similar geological processes shaped by ice. Now, there's an interesting Martian twist. These lobes on Mars are, on average, about 2.5 times taller than their terrestrial cousins. Why? Mars has much weaker gravity, only about 38% of Earth's. This lower gravity allows these sediment waves to build up much higher before they might collapse. So we see these features, and they scream freeze-thaw cycles. But here's a crucial point. This doesn't automatically mean liquid water was flowing. Given Mars' incredibly thin atmosphere, these cycles were probably driven more by sublimation. That's where ice turns directly into vapor, skipping the liquid phase. However, the way these patterns have formed still strongly suggests that ground ice was, and perhaps still is, involved. More lab work is needed to see if you absolutely need liquid water to create these exact shapes, or if ice alone can do the trick. Are these features ancient relics, or did they form more recently? That's still being investigated. Either way, their very existence is a vital piece of the puzzle of Mars' climate history. If Mars once had conditions icy and wet enough to form these lobes, similar to parts of Earth, those areas could be prime candidates for understanding water's role in shaping the planet, and, tantalizingly, for searching for signs of past or even present life. This isn't happening in a vacuum, of course. This research adds to a growing pile of evidence that Mars was once a different world, a planet with a thicker atmosphere, warmer temperatures, and yes, liquid water flowing on its surface. Rovers like Curiosity have already found ancient wave ripples preserved in rock, clear signs of lakes or ponds from about 3.7 billion years ago. These ripples suggest liquid water was open to the Martian atmosphere back then. And it's not just these lobes. Scientists have spotted other periglacial landforms, features shaped by freezing and thawing around glaciers and ice sheets. Think scalloped depressions and polygonal terrain, especially in regions like Utopia Planitia. These are often found close together, just like they are in similar icy landscapes on Earth, and are also thought to be related to the degradation of ice-rich permafrost, possibly due to changes in Mars' axial tilt over time. So every new observation, every detailed image, helps us piece together the complex environmental story of Mars. Understanding how these wave-like patterns and other icy features formed gives us a window into its climatic past, the potential for freeze-thaw cycles, and the crucial presence of ground ice. It's all part of the grand detective story, helping us refine our search for environments that might once have supported life, or perhaps could still do so. That's all for this episode of Cosmic Chronicles. Join us next time as we delve deeper into the mysteries of our universe.